Good morning. In the frame of CE4CE course, unpacking the potential of circular economy for a sustainable, future-proof public transport, I want to give presentation about optimizing of the energy storage system at the Gdynia trolleybus depot in Poland. Oh, the first question is why trolleybus companies enterprises are particularly predisposed to invest in photovoltaics farms. The main reason is, of course, reduction of energy consumption from AC middle voltage supply grid and reduction of cost of electric energy. Also, it allows to stabilize energy prices through partial independence from market fluctuation in grid electricity prices. What is important, trolleybus network has also tram network, has a large spatial availability, so it is quite easy to connect photovoltaic system in different places of the city. And another important element is utilization of large depot roof surfaces or large interconnection hub surfaces for installation of photovoltaic system. What it is important, photovoltaic can help avoid or defer expenditures for grid connection upgrades and higher contractor supply capacity. And last but not least, also visible PV photovoltaic system installation at the depots can potentially enhance social acceptance of traction catenary of transport electrification. Of course, I presented some benefits, but also there are some challenges and risks when investing in photovoltaic farms. The main, very important challenge is what to do with used photo elements of photovoltaic farms, for example, after 10 or 20 years of exploitation, because by 2050, the EU 27 countries may generate between 21 and 35 million tons of end-of-life photovoltaics panels. So, at the present, most of this waste is either landfilled or only partially processed. But in the future, this problem will become bigger, and there's question what to do with these old elements of photovoltaic system. And also there is now limited availability of material passport, environmental product declaration, and insufficient transparency in the supply chain of individual components. Also, very big challenge in case of supply of tram or trolleybus system from photovoltaic system is fact that we are not able to use all generated energy in photovoltaic system because energy consumption in electric traction is unpredictable. So that's why it is recommended to use storage energy system to enhance usage of photovoltaic system, so it increases the cost of installation of photovoltaic system. Also, there are all another challenges related to the fire safety and safety according electric shock protection. And occupation health and safety challenges related to the operation of photovoltaic system. Frequent omission of photovoltaic dismantling and recycling costs in the total of ownership analysis also. It can be important problem in case of calculation of total cost of ownership of photovoltaic system. But of course, in every situation there are some benefits and there are some challenges, so we need to solve this, to use these benefits and to solve these challenges. And In Gdynia, we tried to make usage of photovoltaic system for supply of trolleybuses in the city. A few words about trolleybus system in Gdynia in Poland. Gdynia, it is seaside city on the Baltic Sea. We operate quite a big trolleybus system with 105 trolleybuses and overall length of traction network is around 50 kilometers. We operate 16 day lines and we make 5 million vehicle kilometer per year. So it is quite a big trolleybus system, and trolleybus system is very important part of public transportation in Gdynia and Sopot city, because we have also interurban trolleybus routes to nearby Spa city. It is Sopot city. And a few years ago, we decided to install photovoltaic to make usage of quite a big roof on the trolleybus depot and to install photovoltaic system on the roof of Gdynia trolleybus depot with nominal peak power almost 500 kilowatts and kilowatts, and the installation was part of the public transport decarbonization strategy and enables the real-time use of renewable energy. And this photovoltaic system is connected directly to the DC trolleybus traction network. So we are consuming energy produced in this photovoltaic system in trolleybuses. Of course, it is not connected completely because it is impossible from technical point of view. It is connected through DC-DC converter, and this DC-DC converter controls energy flow between photovoltaic system and catenary. And this DC-DC converter is based on DAB, DC-DC high power converters with full bridge topology with galvanic insulation and enable output voltage regulation. There is basic scheme of this photovoltaic system, so we can see that totally number of the photovoltaic panels is 90, and these photovoltaic panels are connected with in strings with the DC-DC with the converter, with the container with DC-DC converters and these converters are connected to the trolleybus depot, the trolleybus overhead catenary network in depot, and this overhead catenary depot is connected by feeder with traction substation Grabówek, and this traction substation Grabówek supplies the main trolleybus route of the Gdynia trolleybus network on the Morska Street with the length 3 kilometers. So it gives very good condition for consumption of this generated energy. And we see here some results of evaluation of half-year exploitation of this photovoltaic system in trolleybus depot in Gdynia. So we see that generally we generate energy from April, May, June, and in during summer, and during the spring and summer months, photovoltaic system covers around 60-70% of energy demand of substation Grabówek. So it is quite good result. But as I said at the beginning of the presentation, due to uneven, unpredictable generation, energy in photovoltaic system and traction load, in trolleybus supply system, it is not possible to fully utilize the power photovoltaic power plant's potential. So it means that sometimes happen that it could be generated energy in photovoltaic system, but at this moment there are no vehicles in movement, so there is no vehicles which can consume this energy. And it is noticeable, as I presented on this picture, which present usage of photovoltaic generation potential. So it means how much of energy, which could be in most optimistic scenario generated in a photovoltaic system, is in practice consumed by trolleybuses. So we generally see that this resource is not very bad. Even it is quite good, because average of usage of photovoltaic system potential is around 70-80%. So if we take into account unpredictable generation and load of the system, it is quite good result. But especially in weekdays, in Sundays, this usage drops quite a lot to 50-60 of percent. And there is presentation how much energy is not used, so how much energy we can use for another purposes, for example to charge electric vehicles or to supply another buildings or some facilities of trolleybus depot. So we see that it is possible, especially from April to probably to September. So there is some potential to extension of this smart grid system with photovoltaic system installation. And one of the possibilities which we are considering now, it is installing of storage energy system. Of course, it is question of cost benefit analysis, because it is quite an expensive installation, but from the other hand, it allows to increase the usage of photovoltaic system almost up to 100%. So it is one of our plan for the future to install storage energy system. And some conclusions and recommendation, as we see, the photovoltaic system can be a crucial element of the urban transport supply system, tram and trolleybuses. But of course, we need to be aware that usage of photovoltaic system depends a lot on topology of supply system. So it is not solution for everywhere. For example, in Gdynia, in case study of trolleybus depot, there are quite good condition for installation photovoltaic system, because this photovoltaic system is connected to the substation which supplies one of the main trolleybus routes in Gdynia. So it means that it is quite big, very big energy consumption. But in another place of network, this condition can be different. So before installation, we need to make calculation and to check if it is worth to do it. But generally, as it is presented, it is good solution. So thank you very much for attention.